Problem 2-69. Fire! Call 911. A fireboat in the harbor is helping put out a fire in a warehouse on the pier. The distance from the barrel end of the water cannon to the roof of the warehouse is 120 feet, and the water shoots up 50 feet above the barrel of the water cannon. Sketch a graph and find an equation of the parabola that models the path of the water from the fireboat to the fire. Give the domain and range for which the function makes sense in relation to the fireboat. So we've got an illustration here. We've got the barrel. It's shooting the water up 50 feet high, and then it's coming down 120 feet later on the fire here. So a couple ways this can be done. First of all, you know that we are working with a quadratic shape here, or a parabola, and we are given this critical information here that the distance from the barrel of the water cannon to the roof of the warehouse is 120 feet. So they're basically 120 feet apart, and the water shoots up 50 feet above the cannon when they release it there. So you could draw this a number of ways. I'm going to show you a couple of different ways just to show you that you can end up with different answers too. If I thought about it here, and I'm going to pretend my water boat's on this side here, and it's shooting the water out at the fire that's on this side. So I'm going to go ahead here and put a point down first. I need a starting point, so I'm going to say mine is going to be the point 0, 0. So then it's going to shoot out this way. It's going to go 50 feet in the air, and then it's going to end up coming down over here, which is 120 feet away. So I'm at the point 120, 0, which means that midway between I would be about 60 feet, and I'm going to be about 50 feet high. So here is what I would consider to be my maximum of this shape here. So the water comes up, hits there, and comes back down over here. It's not perfect, but just bear with me. So our vertex here, since it's been shooting out this direction, 120 feet total, this would have to be 60 feet in the middle, which makes our vertex the point 60, 50, because it's 50 feet high in the air. Well, now that we know that this information, remember this is our vertex, so we've just found HK. We can use this to help us come up with the equation for this situation. So we're going to be using the general formula y equals a times the quantity of x minus h squared plus k. Well, now that we've identified our vertex already as being the point 60, 50, we can substitute those values in. We have y equals a times our x minus 60 squared plus 50. Next thing now is we notice here that we've got a y, an a, and an x. We need to figure out what our stretch factor is going to be, so we need to figure out an x and a y that will work in here. Well, we cannot use the vertex again because we've already used that in our function. So let's focus on either 0, 0 or 120, 0. Either one should work fine. I'm going to use 0, 0 because it's nice and small. So I'm going to say for my y coordinate, I'm going to put in 0. And we're going to say 0 equals a times 0, because that's my x coordinate. Oops, actually I'll make that blue so you can see which one I'm plugging in there. And then I've got minus 60 squared plus 50. Now it's about simplifying and making sure that we do our steps correctly. 0 minus 60 is negative 60, and then negative 60 squared should end up being a times 3,600. And we still have plus 50 here. And this all equals 0. So our next step here, I'm going to rewrite this because this is a common place where people make errors. They want to add 50 to 3,600. This statement is the exact same thing as saying 0 equals 3,600 times A plus 50. Let's subtract 50 from each side. And we're going to get negative 50 equals 3,600 times A. We divide each side by 3,600. And in the end, we should end up with a value of, if you want to take it here, I can show you. You could do your 50 divided by your 3,600. That gives us a decimal value here. If you want to take that decimal on your calculator and convert it into a fraction, just go to Math. And then number 1 here, we'll convert some number into a fraction. So what do we have there? It would turn into 1 over 72. Now this is negative here, so we're going to have a negative 1/72. So right now we are looking at the function, I'll write it up here so you can see it, y equals our a value, which is negative 1 over 72, times the quantity of x minus 60 squared plus 50. That is our first equation. To check it, graph it, and make sure it still goes through those two x-intercept points. All right, and then our domain on this one for the situation here is going to end up being, you know, from 0 to 120. So our domain for this particular equation is going to be 0 to 120. The range ends up being from 0 to 50. All points inclusive there. Just so you know, if you didn't start at 0, you could still have solved this another way. I want to kind of draw this out real quick. Let's say here that you put in over here that your parabola was going to start at negative 60, 0. And it's going to go 120 feet, so it's going to end up being over here at positive 60, 0. So the whole distance is 120 feet, which means that our point on the y-axis here is going to be halfway between the two of them. And we know that that point then would be the point 0, 50. So, and it's not drawn to scale, it's probably a little off. Oh, that was way off. Let me try that again. All right, just pretend with me because I'm struggling a little bit here. All right, now if we have our negative 60, 0 and our 60, 0, and then we have this point at 0, 50, we can still do the exact same kind of problem. We could say, you know, y equals a times the quantity of x minus h squared plus k, in which case on this one, our vertex is at the point 0, 50. So let's plug in k for 0 and h for 50. 0. We have a times x. Oops, I screwed that up, didn't I? This is my 50 here. It should be x minus 0 squared plus 50. All right, I was wondering what I was doing there. I'm sure you were too. So hk, we put that in there. This is the same thing as saying y equals a times x squared plus 50, because h is just 0. So now we're going to have to plug in a point into our equation to solve it. Let's plug in 60, 0. So let's put in 0 for y. We have a times 60 squared plus 50. 60 squared is going to be 3,600 again, times a. And when we add 50, we get 0. So we're going to subtract our 50 once again. We're going to have negative 50 equals 3,600a. We divide by 3,600. And what you'll notice here is we get negative 1 over 72 again. So what I'm trying to get you to see here is it doesn't matter what point you start on as long as you have the same shape to your graph, or the stretch factor is the same. So our stretch factor is negative 1 over 72, which ends up being the correct value for both of these graphs that start in different places. So our equation, though, would change a little bit in terms of the location. So we'd have y equals negative 1 over 72, because that's our a, times the quantity of x. You could put in there, if you wanted to the first time, the h coordinate, x minus 0 squared plus 50. And then you could simplify it down or leave it like that. That should end up working. So if y equals negative 1/72 x squared plus 50. Last part, it's asking for domain and range again. So for domain, we're going to go from negative 60 all the way over to positive 60. So that's going to be inclusive, so negative 60 to positive 60. And then the range is going to go from 0 to 50. So we've got 0 to 50. And that is about it. This is problem 2-69. Once again, there's a couple different answers that you could use. I'll make sure I clearly mark them here. If you have additional questions, please make sure you take the time to ask your teacher. You don't want to get behind on this stuff because it builds pretty quickly in this chapter. Problem 2-69. Thanks for watching.